Hi everyone. My name is Ankita. My co-speaker unfortunately is not able to make it. He's sick. He's not well today. He's more of a GraphQL security expert than I am, but it's okay. You are in safe hands. I've been doing it for some time now, so this will be a very interesting topic as this is very close to my heart. This is something that we are building. This is something that we have a lot of opinion on because we've done a lot of research. We've have customers using this. We have seen really live the security problems that GraphQL APIs can have. So it's going to be an interesting discussion, and I would love it if it's interactive. So if you have any questions while we are talking, while I'm talking, would love to entertain those. By the way, so I am the CEO and founder of Acto. It's an API security platform. It's a startup. We do GraphQL security, REST API security, all kinds of API security, but GraphQL is one of the very big module that we have, GraphQL security. Okay, so I'm not going to talk about what is GraphQL. I'm guessing everyone knows about this. Why implement GraphQL security? Just a little bit of background on why it matters, why it's important. The top 10 GraphQL security checks for developers and summary. So just if you can raise your hands and tell me who all are developers, GraphQL developers, and do it sort of day in and out. Yeah, about like half of the audience. Great. So I guess, if somebody knows some things around the topic and have some personal stories, would love to hear also. But let me start. Skipping this one. Why implement GraphQL security? So I've tried to get some of the most popular vulnerabilities we've seen in GraphQL APIs around the world. 2021, 2023, and 2023 again. The first one is related to introspection. Really what it allowed was for an attacker to be able to do XSS injection in the GraphQL API for GraphQL IDE. The second one is related to SQL injection. And the third one is authorization checks, and because of which there was sensitive data exposure and all of that. These are CVs, these are vulnerabilities in known softwares, in known GraphQL API softwares. But okay, so now we're going to more talk about why. So we heard these three vulnerabilities. Really, there are a lot of security vulnerabilities that can happen in GraphQL, very similar to REST, but there are certain things that happen more in GraphQL. Now I'll talk about what are the top 10 that you should really take care of. These top 10 have come from our experience working with customers, our experience really looking at multiple applications, how developers have developed the GraphQL APIs, what kind of vulnerabilities they have seen live. Those are the real inputs for these checks. The first one is a very important one. I know some people have opinions on, maybe persistent queries should be the first one and all of that, but this is really the number one. And why this is number one? I don't think I've met maybe 9 out of 10 companies we work with who have GraphQL APIs. They don't follow this, really. This is that common. So really important to talk about, which is disable introspection in production. Now, introspection is amazing. Introspection is a very important tool for the developers who are developing in the development phase to query the schema, to be able to fetch all the queries, data, parameters, everything, but not in production. In production, you don't want introspection to be enabled. Why? Why so? Can anyone answer this? Why should introspection not be enabled in production? Anyone? Yes.
You don't want random folks on the internet learning how your schema is constructed.
Yeah, exactly, right? You don't want random folks. You don't want unwanted users to understand how your schema is constructed. Why so? What if they learn about your schema? What if they learn about your GraphQL APIs? How the business logic work and everything. If they learn about that, they'll be able to do a lot of malicious attacks on you. They'll be able to send malicious payloads, they'll be able to understand your business logic, they'll be able to do business logic attacks on those API endpoints which you don't want. Now, having said that, the only case where introspection in production is fine is for the public APIs. For the APIs you want your users to use, but not the non-public, the private APIs. So this is number one. Make sure introspection is disabled. I can't tell you how many times we see it enabled really in production for really large companies as well. So this is number one really. And it's very easy to know how to figure out if it is enabled or not. The second one, robust authentication, sort of like table stakes, very basic, something that every API should have. Doesn't matter it's GraphQL, REST, gRPC, but again a very common way for attackers to find vulnerabilities, to attack your API endpoints, to get sensitive data exposure, sensitive data out of your application. And how? So what happens if there's no robust authentication? In security world, in application security world, it's called broken authentication vulnerability. And it's really if your APIs are not authenticating users, not validating the authentication well, like for example, the validation is not happening at every request. Something like credential stuffing is a very common attack that happens if there is broken authentication. Let's say, this happened last year in 2023 for 23andMe. 23andMe is this very popular healthcare company which had credential stuffing attack happen. What happened was their login API endpoint, some attacker brute forced really the passwords and was able to log in and fetch all the sensitive information out. And how was the attacker able to brute force? Because the authentication, the login API endpoint was not validating authentication properly. There was broken authentication vulnerability. So that's really what broken authentication is. And the checks that I've mentioned are also very basic, very important to have, but really like lot of things, example validating token for every request, we don't see it. We don't see it in a lot of APIs actually. It's a very common vulnerability we find. Session management, password policies, MFA, these are really table stakes today. So broken authentication. The third one, specific to GraphQL, limit query depths. Now, anyone who can explain what query depths is? GraphQL developer? No, okay. So query depth, I mean, the reason GraphQL is it's amazing, it's different from REST is also because you can do as deep query as possible. You can fetch any query, you can fetch any data, right? It allows all that complexity and depth in the queries. Because of which the con is, it can go so deep, it can really consume a lot of resources. It can be cost intensive, and which is something that you don't want, because let's say if there are multiple nested queries, and if there's a request that is doing multiple nested queries, that can really bring your server down. It can take a lot of time. An attacker can do DOS attack. All of those things you don't want. It can be, it is not just a security issue, it's a performance issue as well. So that's, how do you check for it? How do you make sure this doesn't happen? And I think I've mentioned over here, there's a security check. It's a very simple operation I've written, but basically limiting the queries, limiting the depth. Here I've written 5, right? Like you have to limit those query depths so that even if a developer has, by mistake not made those checks, it's possible, it's really limiting the query depth to 5 and not allowing for nested queries to happen. So that's query depths, and the question that comes over here is, why don't we do persisted queries? And that's the really answer to most of the GraphQL security question. And that's actually slightly nuanced and different topic, and that's why I've put it as number 4, which is use persisted queries. It's the favorite method for most of the GraphQL developers. Allow list. Anyone who can explain what allowed list or persisted queries are? Yes.
The client writes the query is static, and then you basically give the query to the server. The server sort of hashes the query and creates a list of queries that it recognizes. And then when the server starts, accepts requests from the client sends the hash of the query rather than the query itself, along with any variables that are defined in the query. And it's got several benefits aside from just being limited to a fixed set of queries. You also save yourself bandwidth having to send a long string essentially code. Since the server already has it, you can cache the AST so the server doesn't parse the query. And most importantly for security, you know exactly the types of work that the server is going to have to do ahead of time. There's no surprising combination of fields that knocks all your backends offline.
Exactly.
You tested it before you launched the server.
Exactly. I couldn't explain better. So exactly, that's what persisted queries is. It's in very simple way. It's like whitelisting your queries, but it's really what it does is it prevents any malicious user, malicious attacker to be able to send any kind of payload, any malicious payload, because now your backend is actually validating if it is in the allowed list or not. So that's persisted queries, very, very popular way to make sure you're not allowing any malicious attacks on your APIs. Input validation, sort of similar, but like it's more broader concept in the sense that this is so popular in REST API world as well as GraphQL. Input validation is essentially any input you're taking from the user, you're validating if it follows certain format, if it follows certain type and all of that. For example, in this one, very simple example, in the insecure code, I'm not validating the email. In the secure code, you can see I'm validating with a regex. So, so that's really input validation. Email is a very simple example, but it can go as complex as possible. Imagine if I don't do that, some malicious user can do an XSS attack and a SQL injection attack, can actually delete your database, take your database down. All of those things, drop database command. All of those things are possible if you don't do input validation. Number 6, yes.
Just realized something. Another advantage of having the queries pre-recorded like that, the query string never appears in the client. So if the client views source, that's otherwise a way for them to sort of do an introspection, even if the server disables it, because they can see all possible queries and they can gain some idea of what your schema looks like based on what the client claims to be able to query. But if all they see is a SHA, they're not going to get that information.
Exactly, right? So introspection, the number one thing. You should not allow it in production for sure. Very good example there. Secure direct object references. Big word, but really what it means is secure authorization. Now, we talked about authentication. This is authorization. Very simple concept, but hard to implement, and that's why the lot of security vulnerabilities happen over here. In the security world, especially broken object level authorization or broken authorization is one of the most common vulnerability. What it really means is, let's say I'm a user of Uber, I'm a rider, I take rides. I am able to see all of my rides, all of the payment history, all of the history of my rides, but I'm not able to see this person's rides or like any other person's rides. Why? Because Uber's application, Uber's APIs are not allowing me, an unauthorized user, to see other person's objects, resources, all of that data, right? So that's authorization check. And this is a very simple case I'm talking about. It can go as complex as having multiple roles, permissions, all of that. Now here is where authorization checks are hard to implement, and that's something that can happen, that can occur as a very easy vulnerability, and very important to have authorization checks, making sure that you're allowing users only the data, only access to the API endpoints or the data that they have access to, they are authorized to have access to. So authorization checks. Error handling, verbose error handling. So a lot of times, as we are developing APIs, we kind of give all of these verbose error messages. For example, here the message is, cannot query field email on type user, did you mean email? That's too much information. That's not how you should handle errors. The way to handle error is basically, most of the times people do masking of errors. What you can also do is, have like a very generic error, please check your query kind of thing. So make sure you're handling error well. You're not sending a lot of information in your error. You're not having verbose error message, because that's a very good way for an attacker to get hold of a lot of information about your API endpoints, about your data, about how your application is working, and use that in a malicious way. Query complexity analysis. We talked about query depth. Now this is query complexity analysis. Different concept in the sense that query complexity means how complex is your query. It could be, of course, complex because it's nested. It could be complex because of multiple reasons. But really, how much is it consuming your consuming resources, consuming cost, or like how much is the compute cost for the query? That analysis you should do, especially for GraphQL. And the way to do that is you can assign scores to each query. For example, here I've said, limit 1,000, which is a score that I've assigned, that do not let it go beyond 1,000. And I'm calculating that complexity score just to make sure that it doesn't go beyond 1,000. If it goes beyond 1,000, then there might be a possibility of server going down and DOS and all of those things. So very important to do query complexity analysis in GraphQL. Mass assignment checks. This is not very common, but it's a very critical vulnerability if it happens. Has anyone heard about mass assignment? Yeah, it's not so common. So let me explain what it is by giving you an example. Mass assignment really means you're able to edit a parameter in a mass way which you're not allowed to. For example, let's say an API is taking inputs from the user, a form input, like name, email, phone number, password. Now with the form input, the user is also able to add a parameter called is admin equal to true, which the user is not allowed to add. But behind the scenes, API is not checking for it. So if that happens, the user suddenly becomes an admin because there's no check there. And because the user becomes the admin, it has all the admin privileges and is able to access all the data. So that's mass assignment. Little different from authentication checks, but it really in a mass way becomes like a super admin and admin user, and you're able to get all the data out. The way to handle that is, again, allowed fields. You should add a check that only these fields are allowed to be editable, and those checks should happen at the back end so that if anyone is sending something like is admin equal to true, that's checked and that's blocked if it is not something editable, if it is not editable. The last one is excessive data exposure. It's also a top 10 API vulnerability, and what it means is sometimes your API endpoints in the response, it's fine to send some data that the user should be able to see, but sometimes it's not required for functionality. For example, here ID Gmail token is probably not required for the user to see. So having a check on excessive data exposure, that are you sending a lot of data that you should not be sending? Are you masking that data? Are you making sure that you have authorization checks on the data, that you're sending data to only the person who should be seeing this data? Is something that you should put check on. It's called excessive data exposure vulnerability. Very common again. Masking is the best way to sort of handle it. All right. Yeah, just to summarize, we talked about the number one again is disable introspection in production. I think if that happens, the attacker will have pretty much all the information about your APIs, about how your application works, business logic of your application, everything, and you should not let that happen. We talked about authentication, limit query depth. Persisted queries is really the most popular and very loved by the GraphQL community. It's also a developer way to make sure that there's an allowed list and allowed list for all the queries. Input validation, popular again. Secure direct object references, authorization checks, very basic. Error handling, query complexity analysis, not as popular, but still very important, important for GraphQL security. Mass assignment, not popular, but important if it happens. Rare, but it can happen. Excessive data exposure, again, it's popular, but it's not very critical. It's sort of like a medium or high vulnerability. That's it. This is a way to connect with me, but I'll go back here and if anyone has any question. I wanted to ask if anyone knew, if people knew about all the 10 or kind of knew 5, or what is the percentage? Let's say 5. Did people know 5 out of 10? Okay. 10 out of 10? Sort of. Okay. 8 out of 10? Great. Okay. Cool. So I probably imparted some knowledge. Awesome. Any question? Yeah.
So I understand the reasoning to not expose too much information, but to give a good user experience, sometimes it's needed to give like a clear indication of what's going on. Right? Like say say this example, right? Like say, hey, you cannot query this because certain reason. You have to give the specific reason for your understanding.
Yeah.
So is there any standard of best practice to follow? What kind of information are sensitive? Things like that?
Yeah, I think there are certain best practices in the sense that you don't want to be sending out, especially versions of your of the database or versions of things that you're using. For example, I've seen people really sending out MongoDB versions, which you don't want to send out. That's certainly a no-no, right? If you're typing in email password and you say, hey, your password is wrong, those things you should not be doing, right? But in terms of how deep you can go, I think it really depends. General ways to keep it as generic as possible. Don't really send out verbose message, because you don't know, like maybe you're not sending a lot of information over here, but the person is able to capture information from here and maybe other API endpoint and relate those information and make sense out of the business logic and do an attack. That really happens. Attackers are very smart. So if you want to be if you want to be pessimistic, if you don't want anything, any door to be open, you don't want, you don't want any verbose error message here. Yeah.
So the very first point that you made there, which is don't turn on cross-section and production. When it comes to enterprises, there are different life cycles, and production is the most accurate and reliable. All the non-prod ones are in different phases.
Yeah.
Right? And with Agile Scrum, you are on different sprint cycles with different changes. What would your consumers, where would your consumers go to look at what is truly working in production and develop against it? So even your API Explorer needs to point to a production instance so it can render the API reference properly, right?
Yeah, for public APIs, it's fine, right?
No, so these are all protected APIs.
Okay.
Semi-private or protected APIs. So they are behind OAuth, right? So they get authenticated and then they get to doing the introspection to understand what your, your objects and structures and operations look like. And then they start developing it.
Yeah.
So why turn it off?
Yeah, I mean, if you turn it on, if it is not public, if it is behind authentication, if you turn it on, then it's turned on for everyone, right? Like not just for your consumer.
It will be turned on only for the people who have access to it. Who are
Yeah, then it's fine, right? Then it's fine. If they have the token and they can access it, then it's fine, right? Yeah. Do you have any?
I was going to say, the solution that we use is that we have a staging environment that has exactly the same code base. In fact, we transfer images from the staging environment to production, right, without rebuilding them. And so the only thing that's missing in the staging environment is the traffic. And so you can this can be like a process-based solution. Then you can have introspection turned on in a configuration setting in the staging environment, but not in production, right? And it's still the same code base, meaning it's the same schema, right? Like bit for bit, the same schema.
So you have a prod-like environment, but it's not truly.
Basically, yeah. That's one solution. I mean, if you can afford another cluster, but
Yeah, it's always problematic. Yeah, it's generally hard for especially larger enterprises to have exactly same as prod.
Because all our non-prods are behind a firewall too.
right.
Right, so all your dev stage are all behind a firewall, and production is only exposed outside of your firewall. So there's no easy way for your consumers who are sitting outside the firewall to look at your non-prod environments.
But actually, now that I think about it, you don't have to run the whole cluster, right? You just have to run the thing that serves the schema, right?
Right.
And so you have one pod behind a firewall that serves the schema, right? That has the exact same image as the one in production.
So introspection very need to be routed
Yeah.
to that one pod.
Which most devs do anyway, right? Because they don't route to production by default, right? Like when devs do their day-to-day work, they don't go to production, I hope, right?
They get the schema signature from production, right? Generate their code and then start developing against it. For testing purposes, for the data stuff, they come to non-prod, but the schema that they obtain is from prod.
Right. Yeah, so that's what I'm saying, like you can just mirror it back.
Great. I have a question. Is there anything that I've not covered which is probably something that you've seen in your experience as a security vulnerability? So I guess I've covered most. Great. Thank you. Thank you so much, guys.